Changes in brain mechanical properties from traumatic soccer headers.
Chronic traumatic encephalopathy, or CTE, is a progressive degenerative disorder of the brain found in those with a history of repetitive brain trauma. The impact of CTE in NFL players is concerning, but other sports should not be ignored. Female soccer players experience a concussion rate nearly tied with the concussion rate of male football players. In fact, 27% of all injuries suffered by female soccer players are traumatic brain injuries. Our experiment is looking at the mechanical properties of the brain after mild traumatic brain injury due to repetitive soccer headers. We hypothesized that after repetitive hits to the head with a soccer ball, a significant difference in mechanical properties post-impact will be observed, with a reduction in linear elastic modulus.
Our experimental test setup and methods are as follows. The right hemisphere of 4 sheep brains were used as a proxy for human brains. The brains underwent indentation testing pre-impact to get baseline linear elastic stiffness. The brains were then placed in a 3D printed skull and neck proxy, and a ball launcher was used to launch a soccer ball perpendicular to the apex of the forehead of the skull proxy. The brains were then retested to acquire post-impact linear elastic stiffness values. The brains were indentation tested pre- and post-impact in 6 different regions immersed in 1x PBS while confined in a cylinder. A cyclic ramp rate of 1.7 millimeters per second to 15% of the total specimen thickness, which is below traumatic axonal injury, was used to avoid damaging tissue while indentation testing. The brains were individually encased in a 3D printed skull proxy with a 6 millimeter thick forehead holding the brain to a mounted hybrid 3 neck. The same side of the brain that was tested using the Instron was facing outward in the proxy skull to be hit by the ball. The ball launcher was positioned 6 feet away from the skull and neck setup, and the soccer ball was launched 0, 10, 30, and 50 times at a speed of approximately 26 miles per hour, perpendicular to the apex of the forehead.
Here is the cyclic ramp profile up to 15% strain we used. We tested 6 locations with each set of indentation tests for both pre- and post-impact samples. Here we show the force extension curve of the last loading-unloading cycle averaged over each test location of the brain. Red is pre-impact and blue is post-impact. We took the last loading-unloading cycle and extracted stress-strain curves for the loading regime. We fit a linear model to the linear elastic region and determined the elastic modulus by the slope of the fits. We measured elastic moduli in the range of 100 to 300 pascals. Here we see there is no clear relationship between incidences of impact and changes in the elastic modulus. There was a significant source of experimental error coming from inconsistent exposure of the brain tissue to PBS, and a more revealing experimental model would involve impact incidences on a higher order of magnitude to mimic the effects of headers over a player's lifetime. However, the experimental concept explored could prove to be useful in understanding the long-term mechanical effects of the brain from TBIs that lead to CTE progression. With a better understanding of the mechanical effects of header-induced TBIs, mechanical properties could be used as a metric for TBIs' severity and incidences. Furthermore, information like this could be used to inform best soccer practice heading methods and equipment. Thank you for your time.